Have you ever stared into a mirror and for a fleeting second wondered not what was behind you, but what was through it? What if the reflection staring back was not just a trick of the light, but an echo from a place infinitesimally close, yet impossibly far? This question, this fundamental human curiosity about the other side, is the bedrock of our myths, the engine of our stories, and the silent, persistent whisper that has driven explorers to cross oceans, climb mountains, and launch themselves into the void of space. We have always been a species defined by our relationship with frontiers. But what happens when we run out of new lands, new planets, new stars to chart within our own cosmic backyard? What happens when the final frontier is not a place, but a new definition of reality itself? This is the territory we explore today, a place where theoretical physics, astrophysics, and the most ambitious engineering imaginable converge on a single, breathtaking goal. We are not here to ask if other realities exist. We are here to ask a much more audacious, a much more human question. Can we build a doorway to them? Welcome to the ultimate investigation, the final frontier of cosmic construction. Today, we are drawing up the plans for the greatest megastructure ever conceived. This is the Wormhole Blueprint. How to engineer a gateway to another reality. The very concept of a gateway to another world feels like it belongs in the realm of fantasy. It's a trope we know and love. A magical portal, a shimmering rift, a wardrobe leading to a winter kingdom. But what if I told you that the universe itself, in the elegant and complex language of mathematics, already provides a schematic for such a device? This isn't magic. This is physics. Specifically, it is the physics born from the mind of Albert Einstein. His theory of general relativity did more than just describe gravity as the curvature of spacetime. It revealed that spacetime is a dynamic, malleable fabric. It can be bent, stretched, twisted, and most importantly for us, potentially torn or tunneled through. Here lies the foundation of our blueprint, the Einstein-Rosen bridge, known more commonly and evocatively as the wormhole. The name itself is a perfect engineering analogy. Imagine the universe is the skin of an apple. To get from one side to the other, a tiny ant would have to crawl all the way around. But if that ant could chew a tunnel directly through the apple's core, the journey would be drastically shorter. This is precisely what a wormhole proposes to do, not with physical distance, but with the very fabric of spacetime. It is a cosmic shortcut, a topological tunnel that connects two separate points in space, or even time, without the need to traverse the intervening distance. For our purpose as cosmic engineers, the implications are staggering. We are not talking about building a faster-than-light ship, which may be a fundamental impossibility. We are talking about something far more profound, architectural intervention on a cosmic scale. Why build a faster car when you can fold the map? This is the core of our investigation, the transition from a mind-bending physical theory to a concrete engineering problem. The physics tells us that wormholes are a valid solution to Einstein's equations. They are, in a very real sense, mathematically permissible within the known laws of the universe. The universe says, here are the rules for creating a shortcut. It does not, however, say it will be easy. This is the so what moment for our entire endeavor. The fact that wormholes can exist is the clue left by the cosmos. The challenge of actually building and stabilizing one is the greatest engineering detective story of all time. We are moving past the theoretical physicist's blackboard and into the cosmic construction yard. Our task is to translate the arcane symbols of tensor calculus into blueprints, material specifications, and energy requirements. The central enigma is no longer, what is a wormhole? But how do we assemble one? What kind of tools? What kind of materials? And what unimaginable sources of power would we need to take this beautiful mathematical concept and forge it into a stable, traversable gateway? This is where the true scale of the challenge begins to reveal itself. A challenge defined by two titanic adversaries that guard the gateway to the multiverse: energy and stability. They are the twin dragons at the gate, and our blueprint must provide the means to tame them. Let's first talk about energy, and we must do so in terms that border on the mythological. To bend spacetime is to manipulate gravity itself. To tear it open, to create the mouth of the wormhole, requires a concentration of energy so immense that our terrestrial reference points become meaningless. You could detonate every nuclear weapon on Earth simultaneously in a single point, and the fabric of spacetime would barely notice. You could harness the entire energy output of the sun for 1,000 years, and you would still fall short. We are talking about an energy density that is theorized to have existed only in the first fractions of a second after the Big Bang. So how do we, a civilization that still largely relies on burning fossil fuels, even begin to contemplate an energy budget of this magnitude? This is not a question of building a bigger power plant. It's a question of fundamentally changing our relationship with energy. It forces us to look outwards, to the cosmos itself, not as a place to visit, but as a potential power source. The key to unlocking the wormhole might lie in cosmic phenomena we currently only observe with awe and terror. The hearts of stars, the swirling accretion disks of black holes, or perhaps even the mysterious dark energy that is pushing our entire universe apart. The cosmos provides the problem, but it may also provide the solution. The energy required to build a bridge between universes might have to be harvested from the most extreme and powerful engines within our own. But even if we could somehow gather the power of a galaxy, the second challenge, stability, is perhaps even more subtle and treacherous. According to our current understanding, a naturally occurring or artificially created wormhole would be catastrophically unstable. It would be a fleeting, ephemeral thing, a quantum-sized, microscopic tunnel that would snap shut in a time so infinitesimally small that not even a single photon could make it through. Attempting to send something through it would be like trying to leap through a doorway that slams shut 1 trillion times faster than you can blink. Furthermore, the instant any normal matter tried to enter, the wormhole would likely collapse into a black hole. This is the ultimate engineering paradox, a tunnel that annihilates itself the moment you try to use it. Propping it open, keeping the gateway stable and traversable, is the true heart of the Wormhole Blueprint. And the proposed solution is where our journey takes a turn into the truly exotic. To counteract the immense gravitational tendency of the wormhole to collapse, we would need something with anti-gravity. We would need a form of matter that has negative mass, or more precisely, a negative energy density. We would need exotic matter. This is not something you can mine from an asteroid or synthesize in a lab, at least not yet. It is a theoretical substance that would behave unlike anything we have ever encountered, pushing instead of pulling, expanding spacetime instead of contracting it. It would be the ultimate cosmic scaffold, the support struts for our tunnel through reality. Finding, creating, or engineering this exotic matter is the central material science problem of our project. Without it, our gateway remains a beautiful but useless mathematical ghost. With it, the bridge becomes a tangible possibility. So, this is the stage for our investigation. We have a blueprint handed to us by the laws of physics. We have a destination, a new reality, a new cosmos waiting to be explored. And we have our two primary challenges: gathering the energy of the gods and manufacturing a material that defies our everyday understanding of existence. This journey will take us to the edge of known science and force us to peer over the abyss into the unknown. We will have to think like a Type 3 civilization, a species that can harness the power of its entire galaxy. We will have to become detectives of the cosmic code, searching for loopholes in the laws of nature that we can exploit for our own grand designs. This is the ultimate promise of engineering, not just to solve problems, but to rewrite the definition of what is possible. The wormhole is more than a theoretical curiosity. It is a declaration of intent. It is a statement that humanity does not have to be confined to one planet, one solar system, or even one universe. Our ambition is as limitless as the cosmos itself, and our journey to build a bridge to everything, everywhere, all at once begins now. We will dissect the challenges, explore the potential solutions, and lay out, piece by piece, what it would truly take to follow this blueprint and engineer a gateway to another reality. In any great detective story, before we can find the solution, we must first understand the full, terrifying scope of the problem. We must stand before the locked room, examine every detail of the impossible crime, and truly appreciate the genius of the lock before we can even dream of finding the key. In our quest to engineer a wormhole, this is that moment. We stand before the vault of reality, and the challenges we face are not merely difficult. They are so fundamental that they challenge our very understanding of matter, energy, and the fabric of space-time itself. This is Phase 1, the impossible challenge. We are now moving from the optimistic blueprint to the cold, hard list of reasons why this gateway should, by all accounts, remain firmly in the realm of science fiction. These are the colossal forces, the intractable paradoxes, and the seemingly unobtainable materials that form the very walls of our cosmic prison. Our first and most immediate obstacle is one of brute force. It is the problem of initiation, the sheer, unimaginable energy required to create the entrance to the wormhole in the first place. In the introduction, we stated that the energy required would be immense, but that is a profound understatement. Let's try to put this into a proper engineering perspective. The fabric of space-time is not a delicate silk sheet. It is the most rigid, resilient, and unyielding substance known to existence. Its stiffness is defined by a value known as the Planck tension, a force so ludicrously large that writing it out requires more zeros than our minds can comfortably comprehend. To punch a hole in this fabric, even one large enough for a single atom to pass through, requires concentrating energy to a density that makes the core of a star look like a dying ember. We are not building, we are breaking. We are trying to induce a controlled fracture in the bedrock of reality. Let's use an analogy. Imagine trying to punch a hole through a 1 meter thick wall of solid diamond. Now, imagine that wall is 1 billion times stronger than diamond, and you have to punch the hole with nothing but focused energy. This is the scale we are operating on. To create a traversable wormhole, say 1 meter in diameter, the calculations of general relativity suggest we would need to generate a negative energy density, equivalent in magnitude to the positive mass energy of a planet like Jupiter. Let that sink in. We would need to create an anti-Jupiter, an entire planet's worth of mass, converted to a very specific kind of negative energy, and focus it into a tiny region of space. The total energy output of human civilization for 1 million years would not register on the scale needed. We would need to capture and control the entire energy output of a main sequence star like our Sun, not for a second or a day, but potentially for centuries, just to accumulate the necessary power for the initial spark. From an engineering standpoint, this is hurdle number 1, and it is a vertical cliff face 1 million miles high. It forces us to ask a terrifying question. Are we even capable of operating on this energy level? It suggests that the construction of a wormhole is not a task for a planetary species, but for a galactic one, a civilization that treats stars as we treat batteries. But let's assume for a moment that we are cosmic titans. Let's say we solve the energy crisis and successfully blast open the gateway. We have our tunnel. This is where we face the second, and perhaps more insidious challenge, the catastrophic instability of the structure itself. The very physics that allows the wormhole to exist also decrees that it must be an ephemeral, suicidal object. The immense curvature of space-time that forms the tunnel's throat creates an overwhelming gravitational desire for it to collapse. It's a tunnel dug through a mountain of pure gravity, and the moment we stop actively forcing it open, the walls will slam shut with unimaginable violence. And the timescale of this collapse is not seconds or milliseconds or even nanoseconds. The wormhole would seal itself in what is known as the Planck time, roughly 10 to the power of negative 43 seconds. This is the smallest possible unit of time, the frame rate of reality itself. No signal, not even light, could traverse the throat before it pinches off into a singularity. This is not a simple structural failure. It is a fundamental feature of the design. Our cosmic bridge is programmed for self-destruction at the most basic level of physics. The engineering analogy here is trying to build a bridge out of lightning. The moment the flash exists, it is already gone. Any ship, any probe, any brave human explorer that tried to enter this raw, untamed wormhole would be caught in the collapsing throat. They would not simply be crushed. They would be obliterated at a subatomic level as the singularity forms. Their matter and information erased from the universe in a flash of high-energy radiation. This means our blueprint is critically incomplete. It's like having a plan for a magnificent skyscraper that fails to account for gravity. The problem is not just building the gateway. It's preventing the universe from immediately and violently unbuilding it. We don't just need to open the door. We need to install a cosmic doorstop of impossible strength and endurance. This leads us directly to our third and most baffling challenge, the one that truly pushes us beyond known physics and into the realm of the truly exotic, the problem of the construction material. In order to prop the wormhole open and fight its suicidal collapse, we need a substance with properties that sound like they were invented by a fantasy novelist. We need exotic matter. To a physicist, this term has a very specific meaning. It is any substance that violates what's known as the null energy condition. For us engineers, what matters is its practical and utterly bizarre primary property. It must exert a negative pressure. It must have anti-gravity. While normal matter pulls inward, creating the gravity that holds stars and planets together, this exotic matter must push outward, creating a repulsive gravitational force. We would need to line the entire throat of our wormhole with this material, and its outward push would be the scaffolding that counteracts the inward pull of spacetime, creating a stable, traversable tunnel. So, where do we find this stuff? This is the detective's dead end. As of now, exotic matter exists only on our blackboards. We have never observed it, created it, or contained it. It is, for all practical purposes, a hypothetical material. The only place in known physics where something like the required negative energy density has been proven to exist is in a quantum phenomenon known as the Casimir effect, where the space between two very close parallel plates has a slightly lower energy density than the space outside. But the amount of negative energy produced is microscopic, fleeting, and utterly insufficient. Relying on the Casimir effect to stabilize a wormhole would be like trying to hold up the Golden Gate Bridge with a single spider's thread. So we are faced with a materials science problem of cosmic proportions. We need to build our bridge's support structure out of a material that, for all we know, may not even be possible to create in large quantities. It's like an ancient Roman engineer being told he must build an aqueduct, but his only available material is air. We don't know if it's an element we have yet to discover, a state of matter we have yet to create, or if it requires a fundamental re-engineering of the vacuum of space itself. Without this unobtainium, our blueprint is nothing more than a mathematical dream. Finally, let's say we overcome all of this. We gather the energy of a star. We invent a way to stabilize the throat with exotic matter we've somehow created. We have a stable, open gateway. Is the journey safe? This brings us to the fourth major challenge, the sheer lethality of the passage. A wormhole is not a serene, silent tunnel. It is a region of extreme physics, a place where the universe's most violent tendencies are on full display. Firstly, there are the tidal forces. The gravitational gradient inside the wormhole's throat would be immense. For any object of significant size, like a spaceship, the part of the ship closer to the wall would be pulled dramatically more than the part in the center. The ship and everyone in it would be stretched and squeezed, torn apart by gravity in a process aptly named spaghettification. We would need to design a wormhole of truly colossal size to minimize these tidal forces to a survivable level, which in turn would exponentially increase the already impossible energy and exotic matter requirements. But even more dangerous is the radiation. A wormhole connects two distant points in space, and quantum mechanics tells us that even the vacuum is not empty. It is a roiling sea of virtual particles. As these particles travel through the wormhole, they can be converted into real, high-energy particles, creating a feedback loop. The wormhole itself would act as a natural particle accelerator, filling the tunnel with a lethal storm of superheated plasma and gamma rays. Any traveler entering would be instantly incinerated by a phenomenon known as a blue shift radiation crisis. The gateway would become a microwave oven from hell. Therefore, our blueprint needs yet another impossible feature, a radiation shielding system capable of withstanding energies that would vaporize any known material. The bridge must not only be stable, but it must also be a sanctuary, a calm passage through a cosmic storm of our own creation. When you assemble these four challenges, the picture becomes clear. We are trying to build a structure that requires the energy of a star, held open by a material that may not exist, while simultaneously protecting its passengers from being torn apart by gravity and fried by radiation. This is the magnitude of the impossible, and it is only by staring directly into this abyss of difficulty that we can begin our search for the hidden clues, the cosmic loopholes that might just make it possible. Every detective knows that no crime is perfect. No matter how impossible the locked room seems, there is always a clue left behind. A smudge on the glass, a thread on the carpet, a subtle inconsistency in the story. Our investigation now turns to this hunt for cosmic clues. The universe, in its infinite complexity, is not just a set of rigid, unforgiving laws. It is also a place of bizarre loopholes, of extreme phenomena, and of profound mysteries that hint at a deeper, more flexible reality. If the challenges we outlined in Phase 1 are the locks on the door, then the clues we are about to examine are the potential keys. We must now put on the hat of the forensic physicist, examining the most extreme environments in the cosmos to see if they can offer us a solution. We will look into the hearts of black holes, the vast emptiness between galaxies, and the very quantum fabric of reality itself. This is Phase 2, the clues from cosmic physics. The search for the evidence that can crack our case wide open begins now. Our first and most pressing problem was energy. We need the power of a star, or perhaps even a galaxy, to even begin the process of tearing spacetime. So where do we go shopping for that kind of power? The first clue leads us to the most powerful gravitational engines in the known universe, black holes. For a long time, we saw them as cosmic dead ends, points of no return. But our understanding has grown more nuanced, particularly when it comes to black holes that are rotating, known as Kerr black holes. A spinning black hole is not just a passive gravitational sink. It is a colossal cosmic flywheel, storing an unbelievable amount of rotational energy. Surrounding this spinning behemoth is a region called the ergosphere, a place where space-time itself is being dragged around at incredible speeds, like water in a violent whirlpool. Nothing inside the ergosphere can stand still. This right here is our first major clue. The British physicist Roger Penrose discovered a theoretical mechanism, now named the Penrose process, by which we could extract energy from a spinning black hole. Imagine tossing a specially designed container into this space-time whirlpool. Just as it enters, the container splits in two. One half falls into the black hole, while the other is violently ejected, moving faster and with more energy than the original object had. In essence, you are stealing a tiny fraction of the black hole's rotational energy. It's the ultimate cosmic power play. The energy stored in a single, large, rapidly spinning supermassive black hole can be greater than the energy output of all the stars in our galaxy combined over thousands of years. The so what? Here is monumental for our engineering blueprint. It means the universe contains ready-made power plants that dwarf anything we could ever build. Our energy problem shifts from one of generation to one of extraction. It's no longer about building a billion fusion reactors, but about developing the technology to tap into these pre-existing cosmic batteries. Of course, the engineering required to get close to a black hole, survive, and perform the Penrose process is a megastructure project in its own right. but it provides a physically plausible pathway to the energy levels we need. It takes the energy requirement out of the realm of pure fantasy and places it into the category of extraordinarily advanced cosmic engineering. Our second impossible challenge was stability, the need for a mysterious exotic matter with anti-gravitational properties to prop our wormhole open. This seemed like the most fantastical requirement, a true deal-breaker. So, as detectives, we must ask, does the universe show any evidence, even a fingerprint, of this kind of substance? The answer, remarkably, is yes. Our first piece of evidence comes from the quantum world. In 1948, the Dutch physicist Hendrik Casimir predicted a bizarre effect of quantum field theory. Imagine placing two perfectly flat, uncharged metal plates incredibly close to each other in a perfect vacuum. Intuitively, nothing should happen. But Casimir predicted they would be pushed together by an invisible force. This has since been experimentally verified. The reason is that the vacuum of space is not empty. It is a roiling sea of virtual particles, popping in and out of existence. The tiny gap between the plates restricts the kinds of virtual particles that can appear there, meaning there are fewer particles inside than outside. The greater pressure from the particles outside pushes the plates together. The so what is the nature of the space between the plates. It has a lower energy density than the normal vacuum outside. It is, in a very real, measurable sense, a region of negative energy density. This is our first clue. The Casimir effect is physical, laboratory-verified proof that negative energy, the fundamental property required for our exotic matter, is a real phenomenon permitted by the laws of nature. It is, however, incredibly small. But for a detective, even the smallest fingerprint is enough to prove the suspect is real. This quantum clue is tantalizing, but we need a suspect of a much larger stature. And that brings us to the biggest mystery in modern cosmology: dark energy. In the late 1990s, astronomers studying distant supernova made a shocking discovery. They expected to see the expansion of the universe slowing down due to gravity. Instead, they saw it was speeding up. The universe is not just expanding, it's accelerating. There is some unknown energy, some mysterious force that is pushing everything apart. They named it dark energy, and it is estimated to make up nearly 70% of the total energy content of the universe. And what is its defining characteristic? It is a constant, pervasive energy inherent to the fabric of space itself that exerts a negative pressure. It is, for all intents and purposes, a form of anti-gravity. This is no longer a microscopic quantum effect. This is a dominant force shaping the evolution of the entire cosmos. The engineering implication here is almost too good to be true. The universe is already filled with a substance that has the exact primary property we need to stabilize a wormhole. The problem is that it's spread incredibly thinly, with a very low density. So the challenge shifts again. It's no longer, does exotic matter exist? The clue from the cosmos is a resounding yes. The new engineering challenge becomes, can we find a way to harvest, concentrate, and deploy this dark energy? Can we build a machine that gathers this cosmic yeast and uses it to inflate our wormhole? The path is still fraught with unimaginable difficulty, but we are no longer searching for a ghost. We are trying to build a net to capture a leviathan. Our third and fourth challenges were intertwined: the difficulty of creating the wormhole and the lethality of the passage. This assumes we have to build our gateway from scratch, puncturing fresh spacetime. But what if we don't? What if the universe is already riddled with tunnels? This leads us to our third clue, which comes from the very, very small, the concept of quantum foam. At the human scale, space-time appears smooth and continuous. But according to the physicist John Wheeler, if you could zoom down to the smallest possible length, a Planck length, a distance a trillion times smaller than an atom space-time, is anything but smooth. It is a chaotic, bubbling, turbulent soup where the laws of physics are in flux. In this quantum foam, tiny wormholes and short-lived black holes are constantly winking in and out of existence, connecting different points in space and time for infinitesimal moments. The analogy is the surface of the ocean. From a satellite, it looks like a flat blue sheet, but at the surface, it is a chaotic mess of waves and foam. So, what does this mean for our blueprint? It suggests that the universe is a natural wormhole factory. Our engineering task might not be to create a wormhole from nothing, which requires godlike energies. Instead, it might be to catch one of these pre-existing quantum wormholes as it bubbles up from the foam, and then, using the exotic matter we've learned to harvest, inflate it to a macroscopic, traversable size. This could potentially lower the initial energy barrier by many orders of magnitude. It's the difference between building a mountain and simply finding a hill and making it bigger. This idea of finding a pre-existing gateway also has a macroscopic counterpart, which brings us back to our first clue, the Kerr black hole. The mathematics describing a spinning black hole suggests something fascinating about its singularity. Unlike the single infinitely dense point at the center of a non-spinning black hole, the singularity in a Kerr black hole is theorized to be a ringularity. The theory suggests that it might be possible to travel through the center of this ring without being crushed. And where would you end up? Some solutions to the equations suggest you would emerge into a different region of spacetime, possibly through a wormhole. In this model, the black hole itself is the entrance to a pre-built bridge. This is a tantalizing, if terrifying, prospect. It means that traversable wormholes might not be something we build, but something we find. They could be hidden deep inside the most extreme gravitational objects we see in the sky. Of course, this path is riddled with its own perils, like the intense radiation we discussed earlier. But it changes the entire nature of the problem. It turns our construction project into an exploration mission. We would be searching for the right kind of cosmic object that already contains the gateway we seek. The impossible challenges of creation and transit might be solved by finding a wormhole that nature has already built and, through its own physics, has already stabilized and cleared of lethal radiation. It's a long shot, but in the detective business, you follow every lead, no matter how strange. The cosmos, it seems, has provided us with a list of suspects, a murder weapon, and even a potential escape route. We have clues. We have possibilities. The impossible case no longer looks quite so airtight. We have stood before the abyss of impossibility, detailing the colossal forces and unobtainable materials that render our project a fantasy. Then we searched the cosmos for loopholes, for cosmic fingerprints, and overlooked evidence that hinted at a different story. We found them in the spinning hearts of black holes, in the quantum vibrations of the vacuum, and in the very fabric of expanding space. We have the problems, and we have the clues. Now comes the moment of synthesis. This is the part of the investigation where the detective gathers everyone in the room, lays the evidence on the table, and reconstructs the events, revealing how the impossible was, in fact, possible all along. This is the moment we formulate our technical thesis, the ingenious connection that weaves our disparate clues into a coherent, audacious plan of engineering. This is phase 3, the ingenious connection and the technical thesis. Our thesis begins with a fundamental paradigm shift. The brute force approach trying to build a gateway from scratch, near our home world, using our own limited resources, is doomed to failure. It is the equivalent of a single person trying to build a modern skyscraper using only the stones they can carry. The scale is wrong. The tools are wrong. The entire philosophy is wrong. Our new paradigm, our central thesis, is this. We will not fight the universe. We will co-opt it. We will not build our megastructure in a convenient location. We will build it where the universe's own titanic forces are, at their most raw and accessible. Our strategy is one of cosmic jujitsu. We will use the universe's own immense power and exotic properties to overcome its own fundamental limitations. We will build our gateway by finding and taming a dragon, not by trying to build one from scratch. Our blueprint, therefore, is not a simple architectural drawing, but a multi-stage plan for cosmic intervention. The first step in our blueprint is site selection and power acquisition. The clue of the Kerr black hole was not just a potential power source. It is the linchpin of our entire operation. Therefore, our mission begins not with construction, but with exploration. We must become surveyors of the cosmic wilderness, launching a fleet of probes to identify the perfect candidate, a supermassive, rapidly rotating Kerr black hole, ideally one isolated from major star systems to minimize collateral damage. This black hole is not just our power plant. It is our construction yard, our factory, and our primary tool. Once the site is selected, we begin the first phase of construction, the Kerr Dam. This would be a megastructure of incomprehensible scale, a Dyson swarm-like constellation of autonomous robots, energy collectors, and stabilization thrusters, completely encircling the black hole's ergosphere. This swarm would be the most complex machine ever built, a self-replicating and self-repairing entity designed for one purpose: to execute the Penrose process on an industrial scale. Imagine trillions of robotic probes diving into the ergosphere, splitting and sacrificing parts of themselves to the black hole in order to fling back pure, raw energy. We would be mining the black hole's spin, converting its rotational momentum into usable power. The analogy is not of a power plant, but of a planetary-scale hydroelectric dam built on a river of pure spacetime. This structure solves our first impossible problem. We no longer need to generate the energy of a star. We will simply harvest it from a celestial engine that has been storing it for billions of years. With our power plant online and generating an energy surplus that could power a galactic civilization, we proceed to step 2 of the blueprint, the Gateway Initiative. This directly addresses the problem of creating the wormhole itself. The brute force method of tearing a fresh hole in spacetime is too costly and violent. Instead, we turn to our clue from the quantum foam. The universe is already making the component parts we need in the form of fleeting, microscopic wormholes. Our task is to capture one and cultivate it. To do this, a section of our Kerr Dam, a massive array of energy projectors, will focus an unimaginable beam of energy into a single, precise point in space nearby. The goal is not to rip spacetime, but to boil it, to churn the quantum foam into a frenzy, dramatically increasing the probability of a micro-wormhole forming. In the center of this energy storm, we would place a quantum resonator, a device tuned to the specific gravitational frequency of a forming Einstein-Rosen bridge. It's a cosmic fishing lure. When it gets a bite, when it detects a transient wormhole with favorable characteristics, it immediately traps it in a containment field. We would have caught our seed. This is the ingenious connection. We use the macro power of a black hole to manipulate the micro world of quantum foam. We are using a sledgehammer to perform brain surgery. Once the seed is captured, the main energy projectors of the Kerr Dam shift their purpose. They now begin to carefully and symmetrically pump the microscopic wormhole with colossal amounts of energy. This is the inflation process. The goal is to grow it, to expand it from the Planck scale to a macroscopic human traversable size, perhaps a kilometer or more in diameter. This process would be violent and delicate, a controlled explosion of spatial geometry. But as we inflate it, we run headfirst into our second impossible problem, the catastrophic collapse. As the wormhole grows, its own gravitational pull tries to crush it back into a singularity. It needs the exotic matter scaffolding, and it needs it injected in real time as it expands. This brings us to step 3 of our blueprint, the exotic matter forge. Here we connect our second set of clues, the Casimir effect and dark energy. The Casimir effect proved that negative energy was real. Dark energy proved that the universe is filled with a substance that has the exact anti-gravitational property we need. Our thesis is that we can engineer a way to harvest it. We would construct a second, even larger megastructure, the dark energy sieve. This would be a vast, filamentous network of cosmic proportions, perhaps spanning the entire Oort cloud of the star system. Its job is not to create exotic matter, but to slowly and patiently filter it from the vacuum of space. Using principles derived from the Casimir effect on a macro scale, this sieve would create subtle energy gradients that would cause dark energy to pool into collection reservoirs. It would be the slowest, largest, and most delicate filtering operation ever conceived. Over centuries, this sieve would concentrate the diffuse dark energy into a dense, usable, and truly exotic fluid. This fluid is our cosmic mortar, our anti-gravitational cement. As the wormhole is being inflated by the Kerr Dam's power projectors, a synchronized system of conduits would spray this concentrated dark energy onto the inner surface of the wormhole's throat. The negative pressure of the dark energy would push outwards, precisely counteracting the inward gravitational pull of the space-time curvature. This is the ultimate balancing act, a dynamic, real-time stabilization process managed by an AI of unimaginable complexity. The outward push of the harvested dark energy would be the scaffolding that props the gateway open, turning a fleeting quantum flicker into a stable, permanent bridge between 2 points in the cosmos. We solve the stability problem not by inventing a new physics, but by taking the universe's most mysterious component and weaponizing its fundamental properties for our own architectural purposes. We are building our bridge's support columns out of the very stuff that is pushing the universe apart. This three-step process forms our complete technical thesis. Step 1. Harness a spinning black hole for near-infinite energy. Step 2. Use that energy to capture and inflate a naturally occurring microscopic wormhole from the quantum foam. Step 3. Simultaneously stabilize the growing structure by lining it with concentrated dark energy harvested from the vacuum of space. It is a complete, symbiotic system. The black hole provides the power. The quantum foam provides the seed. The dark energy provides the stability. Every impossible problem we identified in Phase 1 is addressed here not with a single magic bullet, but with an interconnected system of cosmic-scale engineering solutions, each one based on a clue the universe itself provided. Even the final problem, the lethality of transit, is addressed by this thesis. By inflating the wormhole to a massive size kilometers in diameter, the tidal forces in the center of the throat would become gentle enough for safe passage. Furthermore, the thick, stable lining of dark energy would fundamentally alter the geometry of the throat, smoothing out the quantum fluctuations and preventing the lethal radiation feedback loop from ever forming. Safety, in this case, is a function of scale and robust stabilization. Our bridge is not just open. It is engineered to be a calm, traversable highway through the heart of a cosmic storm. This is our blueprint. It is a plan that is beyond our current capabilities by millennia, but it is not magic. It is a logical, step-by-step engineering proposal for mastering the cosmos. A blueprint, no matter how brilliant, is merely a promise on paper. A thesis, no matter how elegant, is just a ghost of an idea. Our investigation has brought us to the final, most critical question. How do we translate this cosmic blueprint into cosmic reality? And what happens to us, to humanity, the day after we succeed? We now enter the climax of our story, where theory must become practice and speculation must give way to the roar of celestial forges. This is the grand finale, the moment we lay out the practicalities of a multi-millennial construction project and dare to gaze upon the legacy it would create. This is Phase 4, the construction plan and the legacy. The construction of our multiverse gateway would be the single greatest undertaking in the history of life in this universe. A project so vast, it would make the building of the pyramids look like a child playing with sand. It could not be accomplished by a single generation, or even a single millennium. It would require a new kind of thinking, a new kind of engineering, one that embraces cosmic timescales. The project would begin not with a bang, but with a whisper. It would start with the launch of a single, modest vessel from our home system, the Genesis probe. This would be no ordinary probe. It would be a fully autonomous, self-replicating von Neumann machine, the pinnacle of our artificial intelligence and robotics. Within its crystalline memory banks would be the entirety of our blueprint, the sum total of our knowledge, and one core directive: to travel to the chosen Kerr black hole, replicate, and build. This lone seed, carrying the DNA of our ambition, would journey through the interstellar darkness for thousands, perhaps tens of thousands of years. It would be a message in a bottle sent across a cosmic ocean, a testament to a faith in a future we would never live to see. Upon its arrival at the designated black hole, the Genesis probe would initiate the second stage, the industrial bloom. Its first task would be to find a suitable nursery, a mineral-rich asteroid or a dormant comet in a stable orbit. There, it would land and begin the slow, deliberate process of creation. Using the raw materials of the asteroid and the faint light of a distant star, it would build the first generation of its children, specialized miners, refiners, fabricators, and assemblers. It would create a factory, and that factory's first product would be more factories. This is the power of exponential growth. One probe becomes 2, 2 become 4, 4 becomes 16. Within a few centuries, a single asteroid would be transformed into a bustling industrial hub. Within 1,000 years, a vast, continent-sized swarm of machines would be operating in the system. This swarm is the construction crew for our Kerr Dam. It would be a new form of life, a silicon-based ecosystem of our own design, all working in perfect synchrony. The black hole would be surrounded by a shimmering, growing cloud of industry, a testament to the patient, inexorable power of a single, well-programmed idea. This is how a Type 2 civilization truly works. Not by sending armies of workers, but by sending a single, perfect seed. With the industrial base established, the true construction would begin. The robotic swarm, now billions strong, would begin to assemble the primary structures of our gateway system. The vast energy collectors of the Kerr Dam would be woven into their orbits within the ergosphere. The incomprehensibly large, filamentous nets of the dark energy sieve would be deployed, unfurling across billions of kilometers of space. This phase would take millennia, a slow and silent ballet of automated construction on a scale that defies imagination. Finally, after an epoch of patient labor, the moment of activation would arrive. We, humanity, would likely not be there to see it in person, but would watch through communication relays that have been traveling for eons. The activation would be a cascade. The Kerr Dam would power on, its trillions of probes beginning their coordinated dive, and the system would begin to draw power from the black hole's spin, glowing with the light of a captive galaxy. The dark energy sieve would begin its subtle, persistent filtration of the vacuum. And then, the main event. The energy projectors would fire, focusing their stellar power into the designated initiation point. The quantum resonator would sing its gravitational song, luring a single microscopic wormhole from the foam of reality. The containment field would snap on, and the inflation process would begin. The mouth of the wormhole would flare into existence, a pinpoint of impossible light that would swell into a shimmering, stable kilometer-wide disk, its throat held open by the very anti-gravity that drives our universe apart. The bridge would be open. The work of our ancestors and our robotic children would be complete. And then comes the legacy. The opening of the wormhole would mark a fundamental dividing line in the history of our species, a moment as significant as the discovery of fire or the invention of language. In that moment, we would cease to be a planetary species. We would cease to be even a galactic one. We would become the universe's first known multiversal civilization. The first and most immediate legacy would be the end of distance. A journey to the Andromeda Galaxy, 2.5 million light-years away, would no longer be a multi-billion-year dream. It would be a trip you could take in an afternoon. The concept of habitable zones would expand to include every suitable planet in every galaxy the gateway could connect to. Humanity would pour through this doorway, a diaspora on a scale never before seen. Our civilization would spread and diversify, ensuring that no single cataclysm, no supernova, no gamma-ray burst could ever threaten the survival of our species. We would have bought the ultimate insurance policy against extinction. We would be as immortal as the cosmos itself. But the legacy goes far deeper than mere survival or expansion. The gateway is a conduit not just for ships, but for knowledge. For the first time, we could have a definitive answer to the Fermi paradox. Are we alone? We could open a gateway to a planet a billion light years away and find the ruins of a civilization that died out before Earth was even formed. We could open another and find a thriving alien ecosystem. We could open another and find them. A civilization like us, or perhaps far, far beyond us. The gateway would become the foundation for a true galactic internet, a network of knowledge that could link civilizations across the cosmos, ending our cosmic loneliness forever. And this doesn't even touch upon the most profound possibility, connecting not just to other places, but to other universes. What would we learn from a reality where the laws of physics are subtly different? What wisdom could we gain from a parallel humanity that made different choices? The wormhole would not just be a tool for exploration. It would be the ultimate library, the ultimate university, containing the answers to the deepest questions we could ever ask. Ultimately, the construction of the wormhole would change the constructor. A species that can accomplish this is no longer simply Homo sapiens. The technological and societal evolution required to even begin such a project would transform us. We would have to become masters of energy and matter. We would have to solve the challenges of aging and disease to manage a multi-millennial project. We would have to achieve a level of cooperation and unity that is currently unimaginable. By the time the gateway is complete, we would be a post-human or transhuman species, as different from us as we are from the first single-celled organisms. We would be Homo cosmetis, a species that is no longer a passive observer of the universe, but an active participant in its evolution, an architect of reality. This is the true legacy. The wormhole is not the end goal. It is the crucible that forges us into something greater. It is the challenge that forces us to become the gods we once worshipped. With this power comes the final, most profound legacy: responsibility. A species that can connect universes is also a species that can disrupt them. We would become the guardians at the gate, the keepers of the bridge, tasked with the solemn duty of ensuring that our ambition does not become a curse upon ourselves or upon any other reality we touch. The child who once stared into a mirror, wondering what was on the other side, would have finally stepped through it, and in doing so, would have inherited the burdens and the wonders of infinity. And so, our investigation comes to a close. We began with a question that has haunted humanity since we first looked up at the night sky and saw other points of light. Are we trapped here? Is this universe, this single bubble of reality, the beginning and the end of our story? We framed this not as a philosophical query, but as the ultimate engineering problem. Our case file, the Wormhole Blueprint, seemed at first to be a catalog of impossibilities, a testament to our own cosmic insignificance. We stood before the locked room of reality, and the walls seemed infinitely high. We documented the case against us, the godlike energies required, the suicidal instability of the structure, the need for a mythical exotic matter, and the lethal dangers of the passage. The evidence seemed clear. The gateway was a dream, and the universe was destined to remain a collection of isolated islands of light in an uncrossable ocean. But a good detective never accepts the first, most obvious conclusion. We dug deeper. We dusted for cosmic fingerprints in the most extreme environments in the universe, and we found them. We found our first clue in the ferocious spin of Kerr black holes, identifying them not as points of no return, but as colossal power plants waiting to be harnessed. This was the key to the energy problem. We found our second clue in the subtle quantum whispers of the Casimir effect and the overwhelming shout of dark energy, proving that the universe was not only familiar with the anti-gravitational properties we needed, but was in fact filled with a substance that possessed them. This was the key to the stability problem, and we found our final, most profound clue in the chaotic bubbling of the quantum foam and the theoretical heart of a spinning black hole, suggesting that the tunnels we sought might not need to be built from scratch, but merely found, captured, and enlarged. With this evidence in hand, we pieced together our technical thesis. We moved from impossible to a coherent, albeit monumental, plan of action. We would not fight the universe. We would enlist it. Our blueprint detailed a path forward, a multi-millennial project initiated by a single, self-replicating seed, which would grow into an industrial swarm capable of harnessing the power of a black hole. With that power, we would seize a microscopic wormhole from the quantum foam and inflate it, all while lining its throat with concentrated dark energy harvested from the vacuum itself. We transformed a list of insurmountable problems into an interconnected system of cosmic-scale engineering solutions. We laid out a plausible, if futuristic, construction plan and dared to imagine the legacy it would create: a civilization unbound, the end of distance, the end of cosmic loneliness, and the fundamental transformation of humanity itself into something greater. A species that is not just a resident of the cosmos, but one of its architects. But as we close this case file, we must reflect on what this entire investigation truly means. The Wormhole Blueprint is more than a technical document for a hypothetical megastructure. It is a mirror reflecting our own deepest nature. The drive to engineer a gateway between realities is the ultimate expression of the same fundamental human impulse that led our ancestors to cross continents, to sail unknown oceans, and to take their first tentative steps off our own world. It is the spirit of the explorer, the curiosity of the scientist, and the ambition of the engineer, all magnified to their logical, cosmic conclusion. The value of this blueprint is not just in the destination it promises, but in the journey it would demand. A species that could seriously undertake this project would have to become a better version of itself. It would require a unity of purpose, a vision that spans millennia, and a profound understanding of its place in the universe. In striving to build the bridge, we would become the giants capable of crossing it. This is the real purpose of Fronteras de Engenharia Cosmica. These investigations are not mere fantasies. They are thought experiments that push us to the very limits of our imagination, and in doing so, they teach us about who we are and who we could become. The pyramids, the great cathedrals, the voyages of the Apollo program, these were all, in their time, projects that seemed to border on the impossible. They were humanity's way of reaching for something beyond itself, of leaving a permanent mark on the world that said, "We were here, and we dreamed big." The Wormhole Gateway is the cathedral of our ultimate future, a structure built not of stone and glass, but of spacetime and starlight. Its purpose is the same: to connect us with something larger than ourselves, to elevate our perspective from the terrestrial to the transcendental. It's a declaration that the laws of physics are not a prison sentence, but a set of challenges, a grand puzzle laid out for us by the cosmos, and our purpose is to solve it. In the end, this entire epic multi-millennial saga of cosmic construction, this tale of black holes and quantum foam and energies that dwarf the stars, all comes back to that simple human moment we began with. It all comes back to that person staring into a mirror, wondering what lies on the other side. That curiosity is the fire that fuels all our engineering. It is the engine of our civilization. And as long as that fire burns, we will never stop drawing up blueprints for the impossible. We will never stop looking at the frontiers of our knowledge and asking, can we build a way through? Our investigation today has shown that while the path is long and the challenges are monumental, the answer is not a definitive no. The universe has left us clues. It has shown us that the potential is there. The final variable, as always, is us. Our courage, our ingenuity, our will to reach for the stars, and perhaps one day to build a doorway to the next one. The stars are our heritage. The cosmos is our birthright. And the future is something we will not just discover, but something we will build.